Okay, so hey everybody, let's continue working on blind 75 curated questions for LeetCode essential questions. Today I'm gonna continue working on array sections, and I'm gonna do these subarrays. So the assumption is that in the interview we're gonna start with the easy. We're gonna start with an easy question, which is solving this maximum subarray. And then we're gonna jump into a slightly harder question, which is medium in LeetCode, which is called maximum product subarray. So let's do it. Okay, so first question is the maximum subarray question. So question says, we're given an integer array nums, and we need to find contiguous subarray, which means the elements are continuous from I to J. So in this question, if we have an array starting with -2 and non-sorted array ending with 4, we need to find the maximum sum of subarray. In this case, we have 4, -1, 2, 1, which is the sum of 6, and which is the largest. So if we include -5, then the answer is gonna be 1. If we start from -3, then the answer is 3, which is less than 6. So yeah, and in this example 3, I think this is 5 plus 4 is 9, minus 1 is 8, and then plus 7 is 15, 15 plus 8 is 23, so that's why the answer is 3. So the goal is to return the sum. The goal is return the sum of nums, which is I and j, where nums of I and j, so where that sum is the max. Okay, what's the constraint? Constraint 1. Okay, is the number sorted? So nums are not sorted. Actually, does this impact our question? Maybe yes, because if the numbers are sorted, we just need to find the point where the positive integer is starting. So we can actually use binary search to find the starting index of positive numbers. So we couldn't. So we cannot use binary search. But if we sort and binary search, it is, so the runtime is sorting takes n log n. If this is optimal or not, but anyway, that's the situation. We are not sorted, and length of num is always bigger than 1. Okay, so no empty array, no empty input. Okay, which means edge case should be, so edge case is if length of nums equal 1, then we can return nums of 0. So what about constraint 3? Do we have any duplicates? Yes. So we have duplicates. Actually, does having duplicates matters or not in this situation? I don't think it matters. Even if we don't have duplicates, or we do have duplicates, we need to either sort and do the binary search, or we need to, do the loop. So actually this constraint 3 duplicates doesn't really matter. So how are we going to solve this question? So as we mentioned, binary search, so sort plus binary search takes of n log n. Now, is this the first test? I don't think so. So idea 2, I think we can use dynamic programming. Dynamic programming. So what I mean is that for each num, so get so dp of element I is the maximum of the current number, or dp of -1, I minus 1 plus the current num. So what I mean is that if we have, so as an example, if you have this number, and then I is gonna start with from 1, so 0, 1, 2, 3, for example, and then we only have one number for I. 1 is bigger than -2 plus 1. So we're gonna do is 1. So if it's -3, should we continue 1 plus -3 or just -3? 1 plus -3 is bigger, so -2. And at the number 4, 4 itself is bigger than -2 plus 4. So, and then we just continue so by doing this, we're gonna get 6 as a result. So DP, dynamic programming is useful, especially when we have array of integers and we want to compute maximum of something. So I'm gonna use that. What's the runtime? So runtime is of n, because we only traverse each element once. So yeah, let's do it anyway. So I'm gonna first get the length of nums, and then create the DP. So DP equal so DP, I'm gonna first declare as nums of 0. That's initial number, and then times the length of nums. So that's DP, and then we want to also declare answer. Answer is also, we should start with nums of 0. That's the starting point. So yeah, let's use for I in num in enumerate of nums. Actually, we already have done the first index, so we can start from second index, starting with 1. And then in enumerate, we can define in which index is the I starting from. So this 1 is representing index I. Okay. So what are we gonna do? What we're going to do is the dp of I is the max of current num, or dp of I minus 1 plus num. Now, because we start from 1, we don't have to care about 0 minus 1, because we're starting from 1. So we can always so this dp of I minus 1 is always guaranteed to be some number. Okay, so that's dp, and if this number is actually bigger than answer, then let's replace. At the end, we just want to return an answer. Now, we also want to do the edge case. So the edge case that I created is that if the length of 1, then we want to return nums. Let me just copy and paste. Okay. So if the length is 1, then return nums. I think this is enough. Ooh, out of index. Let me do the print. So list assignment index out of range. One, two, three, four, five, six, seven, 8. Okay. I see. So I think the reason is because we need to set the n is actually length, so that dp length has the same length as input. So then this question has passed. Okay, so now we delete this debug. Okay, so let's do the example edge case. When we have only one number, great. Okay, what about example 3? Great. So let's submit once. Okay, so runtime is 54 and memory is less than, so above like top 40% or something. So now interviewer is gonna, I can easily say that interviewer is gonna ask follow-up questions that can we do it faster, or can we use less memory? So because in terms of memory size, let's do the analysis. So memory usage, we are declared a constant n, constant answer, which is fine. These are constant, but dp is open due to dp. So can we do better space? Can we do a constant space? I think we can. So my optimization will be, so instead of using dp array, use temporary variable as integer and store previous, not the temp. We can actually just say it's previous, store the max into previous. Okay, so let's do it. So now we're going to delete this dp, and instead of calling dp, I'm gonna name it previous. So this is previous. Okay, so now we replaced it, and then if the previous is bigger than answer, then the answer is previous. Okay, so previous right. So we need to create previous equals nums of 0. Great. Yes, so now it's much faster, and memory usage is 15. So they say there's no change in terms of memory usage, but I don't think so. I replace DP array to the constant previous. So this is, in theory, this is all constant, which is much better than open. So yeah, that's my result. Okay, so I was going to say, I was thinking of continuing my next follow-up questions, but the video length is getting longer and longer. So I'm gonna first stop here, and then as part 2, I'm gonna continue a second question as a follow-up. So thank you for watching.